A web-based analysis and visualization environment, the acronym WEAVE, a lofty ambition with, we think, practical goals to enable the interactive data visualization of any available data anywhere by anyone for any purpose, of course under some constraints and controls. And we're sponsored by Open Indicators Consortium, which is co-directed by George Greenstein, a colleague who director of Institute for Visualization and Perceptual Research. I direct the Center for Industrial Competitiveness. Charlotte Kahn, well known for many of you here, director of world-class Boston Indicators Project. The founding members are 4 metro regions: Boston, Atlanta, Chicago, Columbus, 3 statewide agencies: Connecticut, Rhode Island, Connecticut. Each of them are themselves complex membership organizations. The one at the bottom is Atlanta. 3 types of visualizations in broad categories: exploratory, interactivity to discover underlying structures, trends; confirmatory, test hypothesis; presentation, where the result is high-quality visualization to present data. This is just a collage of different kinds of very sophisticated visualizations. Exploratory, discover that homicide victims and perpetrators tend to be similar in age as spouses and partners. Confirmatory, Umass full experience is very large systems, data that's scalable, connected to annotation systems and recommendation systems built on session history, so that users will have provided suggestions on what they next want to do. Here's an example of Boston. This is polygon census tract data. Underlying it is parcel level data. This is point data, schools, hospitals, and police stations. So these interactive, multiple visualization on a single page. Here the active layer is schools, high performance levels, performance levels, educational attainment, educational testing scores by school. The boundaries are school districts. This is a U.S. counties example where the 3 visualizations, I'll describe the level of interaction. Here we have a right-click functionality where you can probe over a single point. Options come up to search the geospatial and the attribute dimensions, Wikipedia, Google, etc. Here, different color schemes. We have 30 color schemes built into this. Unfortunately, the map shows per capita CO2 emissions as green for high emitting Arizona here, counties. This is time slider. Most of you are familiar with time sliders. This is percentage of the workforce in Arizona counties that are technical personnel. And we allow this to happen. Boy, that's one that's called probing. You probe on it for any one visualization, and it's highlighted in all the others. So that this is health data, I believe, and this has to do with physicians per 100,000 population in various cases of a illness. Here, selection can be on a map, and you can have the option to remove what is selected on a map or select off scatter plot, histogram, or bar charts. It can remove those and create a visualization with those that remain, or the selection can be the basis of creating a new subset. Or you can do this with incorporating gaming technology with cooperation, not with competition. And so this could be 2 non-co-located people and more that could be in sequence exploring data visualizations on the internet. So the achievements are in current releases: very high performance, very fast response time, broad usability, choices for color deficient, 8% of males are color deficient, visual analytic tools with these linked visualizations, linked with statistics and computational service architecture. These are examples of what I've done with undergraduate students, and could move down in what are plan proposals to high school: employment data, educational, housing, and foreclosure, crime, water quality data, and incorporate it into the LEAP system. Second year development, which we just began: personalization by state and preferences, collaboration, session history, also ontology, so you can search across different databases for participants, and nested indicators. Pursuing this consortium is supporting common data development. This is architecture: client in Flex, running in the browser, talks to central server over web services to get modified data. Applications already linked are open source R statistics and GeoServer. The overview here is from the consortium member server through users to support internet-based technical assistance, training, joint development with tools for customization of website development, embedding these interactions into it. Plans for the future, the rest of this year and the 3rd year: tools for comparison similarity studies, real-time feeds, ontology editor, vision impaired user supports, report generator with dynamics animation and embedded interactivity into reports, intelligent visualizations.